Namaste, and thank you. This cute little girl on this picture is my daughter, Vida. She was making pancakes last week, and since I'm here, it's too late. You're not going to throw me out of the stage, so I just use my chance. But let's move on. My name is Mathieu Henri. Yeah. You can find me online as p01. I am a software engineer at Microsoft, but I am not a classic software engineer. My computer background comes from the demoscener, this movement that pushes the technical and artistic limits of pretty much any platform. I love to get things on the screen, or to get pixels on the screen, and to experiment and push further these experiments. This is how I learned to code, and this is how I introduced children to coding in the code club that I started 2 years ago. At Microsoft, I work on the Midgard applications, a set of high-value components that you can see in Microsoft 365. Think Outlook, Office, OneDrive, Word, Excel, PowerPoint, all that on all platforms. These high-value components are the profile card, which is information card that you see whenever you see a picture of the name of someone, contact editor, photo editor, profile picker, which is how you get at mentions in all these, in Outlook and so on. So we target many platforms, many workloads or host applications. We are quite a few developers working on a mono repository with many packages, with a relatively big code base. That gives us many opportunities to break things. So today, I would like to share with you how we approach end-to-end testing a world of web, mobile, and desktop applications. I will share some learnings and improvements we did in the field, and some of the road ahead of us. Obviously, Midgard and the Midgard application did not start at that scale. It started much smaller as a technical bet. My team previously built a version of a profile card in one workload, one website. So we saw the opportunity to bring this user experience across more Microsoft products and bring coherence to these Microsoft products. Thanks. So we saw this opportunity to bring coherence by transforming this profile card into a reusable component. So starting in one workload or one host application made everything really easy peasy, because we were in just one workload, so we knew and somehow controlled the whole stack. So when we found a bug or a styling issue, we could fix it or work around it to not impact the workload, so that our fix will not break the workload further. So we used TypeScript because it was really nice to get the strong typing, and it allowed to get immediate developer feedback. So right in your editor, you could get the typing and code completion, and you got all the APIs were exposed. It was really convenient. The basic logic is tested through unit tests, as we all do. For the rest, that was a bit sad. We were doing a lot of manual testing. We were doing manual sign-off in 5 browsers. Yeah, this is not great, but it got us there. It proved that we were able to build this reusable profile card, and everything grew from there. So we developed new components, and Midgard was born. So we started from a profile card, and then we added contact editor, a photo picker, and we reached more platforms and more workloads. But then, as we reached more platforms, we did not control the platform or the environment. We did not control the whole stack anymore. So we saw many style issues, and our testing matrix just exploded. We could not test all that manually. We started to write automated end-to-end tests with a focus on visual and performance regression, because that's what really hit us the most. End-to-end testing comes in 2 parts. The automated testing as the first part, and then later we will look at the second part, the visual regression testing. For the automated testing, each platform knows how to test itself. Each platform has its own way to automate tasks. So to run the test, you need an automation framework. And because of the time constraints of the talk, I will mostly cover web and native platforms. So we went shopping and started to implement end-to-end tests, and we came up with this totem of automation frameworks. On one side with web and native on the other side. So for web, you have Selenium, which is very old. It supports pretty much every browser on Earth. But the problem is that it's a pain to set up. And it's even more painful to write tests and debug them. WebDriver makes that a little bit better, but it's still fiddly. There's a new testing framework tooling called Cypress, which is absolutely amazing. But it only works in Chrome. And IE11 support is not negotiable for us. We support all the Microsoft products, and we have to support IE11. So in the end, we went for Puppeteer, which is a high-level API on top of a Chrome DevTool protocol. So it works in Chrome, but the Google team also implemented a bridge for Firefox, and there is a more basic bridge for IE11. And it also has a very nice API and TypeScript typing, so it's really convenient. On the native side, you have Appium, which supports iOS, Android, and Windows. But the problem is that the TypeScript support and Windows support is fairly poor. It's been a problem. So in the end, the team in charge of doing the Windows application or targeting Windows platform went for WinAppDriver, which supports all Windows executable formats and has very good typing support. Now that we had an automation framework, it was about to look at the testing strategy. So the main idea is to open an application with the build we want to test, and the code to test all your scenarios and request screenshots from your automation framework. So for that, you can either inject the test in the build, or the build can import the test. So, and the test can be run in a live application, a live website or live host application, or using a test application. And you can also do that using live data or using mock data, or you can also replay network calls from some applications. The native platform, they have it a bit easier because on native, the views are fairly isolated from the rest of the views and the styling are fairly isolated from the rest of the application. So they were able to import the test, statically import the tests in their build, and they could run that in test applications because it's so isolated that there's hardly any point in testing in the live applications. And they could do that using mock data or replaying network calls. For that, they use Poly.js by Netflix. On the web, our testing surface is much bigger. We have to face many workloads, many browsers, but we also have to face global CSS and global JavaScript, which can, global CSS and JavaScript from the host application that can interact with us, and our own CSS and JavaScript that can interact with the application. So we had to, we can inject the tests from the automation framework or import them from the build. That's fine. Both strategies are in use and they work very well. But we have to use live applications because of this interaction with global CSS and JavaScript. So far, we use live data because the data that we surface in Outlook is not the same as the data that we surface in, say, OneDrive or Office.com. And testing against live applications is a curse and a blessing. It is a curse because we are exposed to the reliability of the whole chain. So we are testing everything like in production. So if something goes down, and there are many points in the chain, then our tests go down. So it's a little bit annoying. But because we test in the live environment, that allows us also to do some performance measurement, which is fairly nice. But I think we can learn a bit from native, and we can do, or we can achieve the same coverage using mock data or replaying network calls, like they do on native. So with this, with the finding the automation framework, designing the way that you run the test, you have everything to test your scenarios, request screenshots from your automation framework, and in the end, what you get is many screenshots. And it can be many, many, many screenshots, like thousands. Or it can also be not so many screenshots if you build your test as packages that depend on the code that they test. And then, by following the dependency graph of your packages, you will only run the end-to-end test for the packages that you did change. So then you get much fewer tests, or far fewer tests. Now, let's talk about the second part, the visual regression testing. So we saw that all we get from the automated test is screenshots. And it doesn't matter where or how they are produced. They are just screenshots. We can diff them or compare them with JavaScript. That makes the visual regression testing platform agnostic, which is where we can bring some value across platforms and projects. Can you see the colors on the screen? It's supposed to be red here. Is it red? It's black, okay. Okay. I swear it's red. So the industry standard for image comparison is pixel match by Mapbox. And using it, we can see the difference between our candidate and baseline screenshots. And that's a huge step forward. So here you can see these red pixels that show where pixels change. And it's really, really cool. But when you look at that image, imagining that the black pixels are red, can you tell what is happening? Can you tell me whether you would accept that change or not? No. Me neither. So that's a bit annoying. By only showing the differences, we lost all the context about the change. So you could say, OK, we can then in the report, we can also load the image, the baseline image, and the candidate image. But the problem is that in the big building or big tool, these images can be stored in different storages that can be behind an access token that you need to retrieve in your report. So that's a bummer. You cannot really use that. So I wrote a new screenshot diffing library, taking two sets of images, not just two images, but two sets of images. And it generates side-by-side screenshots. And it works just like a git diff, but at the pixel level. So what you see is something like this. In the middle, you have what you saw before, so in red, the absolute diff. And on the right-hand side, you see your change with a ghost showing the pixels that did change from master. And on the left-hand side, you see the master screenshot of your baseline with, again, here, a small ghost showing how you change in your pull request. So if you look just here at this thing, it is impossible to say what changed. But now if you look at your candidate, at the change, you see that you did change the string LinkedIn profile to LinkedIn, and just everything moved a little bit. And then it's fine. You just accept that change, done. So this very simple change of combining the two screenshots and adding the ghost, like you would see in a git diff or in a pull request, makes a huge difference, because now these screenshots, they are very easy to understand, and they are actionable. So looking again at the first change that I showed you, but well, everything was red, black in the middle, and it was impossible to understand what was happening. Now you look on the right-hand side, you see a change, and you just see that the text went down, and one of the texts is now a little bit bigger. And you get a rather clear picture of what happened. Here in that change, we adjusted the margins and the typography to match those of LinkedIn. This is to show LinkedIn data in the profile card. And that change was, OK, no-brainer. We just accept it. As we use this screenshot diffing library, we kept improving it. We made it completely standalone. I did a low-resolution highlight to small changes. Let's see. Can I use the mouse cursor? Yay. Awesome. So here you can see like a low-resolution highlight showing small pixel differences. And also, as the screenshots are diffed or compared, I build a hash of the pixels that are different. Using that hash, you can actually deduplicate the same changes in your visual regression testing. So if you change a button to add a margin, 10-pixel margin, you will see this 10-pixel margin affecting all your screenshots. And then using this simple hash, then you can just remove all the duplicates, and you would see that diff only once. We also optimized all the pixel operations, like a heck. It's getting really fast, and we also enabled it to run in multiprocess. The input of this library is two folders of images that can have thousands of images. And because it runs on multiprocess, nowadays it can diff about over 1,000 screenshots in 1 minute, and that includes the decoding of baseline images, candidate images, and also the encoding of this screenshot diffing. So it works very well for us. We've been using this for several months. And the nice thing is that it is available on NPM. You can NPM install screenshots diff. The repository will be public shortly after I come back from the conference. And hopefully you can experience wicked fast side-by-side screenshot diffing. I would love to hear your feedback about the library, how it works for you, and how it can help you improve your end-to-end test. So we talked about automation frameworks, about end-to-end test and visual regression testing, but there's a lot we can do even before running end-to-end test, and that is component testing. This is to test our components in isolation, and Storybook is it's basically the industry standard. Everybody uses Storybook to do component testing. And we are embracing it ourselves to test our simple components and also to test them in a responsive manner. So we can test our components in containers that have a different size. And testing components in isolation makes for very fast and very reliable test. So this is perfect when you're in full control of your whole stack. If you develop an application and everything you write is only targeting this application, you should use component testing because this is extremely fast and reliable. But if you build reusable component like we do with a Midgard application, you will see that the isolation that you get is far from a ground truth that you get in end-to-end tests when you test against the live application. So it's just another tool in your tool chain. Storybook supports all sorts of add-ons, including one called Chromatic that does visual regression testing. But unfortunately, like with Pixel Match, the screenshots that you get from Chromatic are a little bit difficult to understand, and they are also, they take some time to get used to know really how to treat them. So this is where our new screenshot diff library could help visual regression tools like this one to get more actionable. Thank you for having me. Again, my name is Mathieu Henri. I'm available online as p01, and I hope this was helpful. And I would love to hear your feedback about the screenshot diffing library and how it can help you. Thank you.